So this is going to be the lab for double replacement. This would normally be done in class, but obviously we can't do that. So we're going to do the work, but we're not going to do the actual chemical reactions, unfortunately. So what you do for the work is you're basically going to be mixing, if you look at this, it says box 1. The chemicals that are going to be mixed in box 1 are AgNO3 and FeCl3. For box 2, it would be AgNO3 and Ki. For box 3, AgNO3 and NaOH. And so you get the idea where the two chemicals meet on the top and the side. That's what two get mixed in the box. There are 19 reactions that you're going to be doing. I'm going to do one with you. I'll send out an answer key and then show you how to do the rest. But you are going to have to do, I'm going to show you 1 through 4 on the answers, and then you're going to have to do 5 through 19 and turn them in. So let's get started. So for chemical 1, if you remember, it was, so you're going to need this sheet right here. This is going to be the answer key. Or I'm sorry, this is going to be the worksheet. And the chemicals that we're going to mix are going to be these two. AgNO3, and then this is reaction 1, so I put a 1 there. And so you're going to be doing the exact same thing that you do in the notes for this reaction. You are going to have to predict the new products, figure out which one dissolves in water and which one does not, balance the equation, and then under here you're going to put the names, and then you are not going to do an observation. Let me see if I can do this. And then you are not going to have to do an observation. So I'll do one more with you. Swap the metals. It does not matter which one goes first and which one goes last. So if you put the AgNO3 first or the FeCl3 first, it doesn't make a difference. Rewrite the products. So Fe is going to be with NO3. Ag is going to be with Cl. Notice I didn't write Cl3 here. The reason it is a 3 here is because of the oxidation states. So when we assign the oxidation states, let's do this. NO3 as a group is -1. That makes Ag +1. The halogens, we're going to have to assume that they are -1. That's their most common oxidation state. So that would make this +3. Okay, so that's why this is the way it is. You're going to do that with all the halogens. And if there's other ones, if there are other elements where you have to make the assumption, I guess I will go through and pick those out, but I don't think so. I think it's mainly the halogens in this case. Now I take those oxidation states, transfer them over. Do the crisscross. So it's FeNO3 3 times and just AgCl. We can then balance. So to balance this, I would say there's 3 chlorines. So I put a 3 there. There's 3 NO3s here. So I put a 3 there. That gives me 3 Ags. I have it. That gives me 1 Fe on both sides. And so that's balanced. The next step is to figure out which one dissolves in water and which one doesn't. So this is easy. NO3s always dissolve, no exceptions. Table F. So I can always give the NO3 compound, whichever compound is bonding with the NO3, they're always going to get an AQ sign. The starting materials are always going to be AQ. You don't have to figure those out. And then the ending materials, one of the two is going to be the solid. And so there's my solid, and then I just name them. Silver, nitrate, iron. I'm skipping the Roman numeral for a reason. Let's double check with silver and iron if they need Roman numerals. Iron obviously does. I don't remember if silver does. Silver does not. So silver's good. So silver nitrate's fine. Iron needs a Roman numeral. It's Roman numeral 3 in this case because the oxidation state is 3. And then I just swap them. So iron 3, nitrate, and silver chloride. And so that is everything you need to do for problem 1. there is 18 more. This is going to be due when we come back to school.